This is Chapter 1, Part 3, or Part C, however you want to call this thing. So, continuing on what is a variable with this, and in your book it talks to you about the different data types, int, double, and the size of it with everything that you're doing. This is how you declare it. You did this in 1436 in C++. It's the same syntax. I just want to remind you a couple of things. What does an equal sign means? It means the right side equals the left side. This is your identifier. Identifiers are what? Variables, functions, and constants. This is your data type. In this case is an int. So that's how you declare a variable. Same way as you do in Java with it as well. Here's what it looks like in memory, what actually takes place. This is what you're doing. The Java virtual machine accidentally decides where the value we place with this thing. This side is what we call the hexadecimal side. Isn't it easier to remember what the variable called length, and you put 72 in there versus the hexadecimal? So that's what we're talking about, is when you actually compile this thing. Okay? You have what's called the compiler. The compiler compiles the compiling is the process with this thing. So when you compile in a text editor, we're going to use is the notepad. All the notepad that we're actually compiling is through notepad. Where I'm not going to use Java Bean, I'm not going to use Eclipse in here. It's just too messy on an online class with it, any class with this thing. Alright? Your .java is your source code. Your .class is equivalent to your executable when you did in 1436. Here's a .class file. Alright? Key things here. Source code, still have that. Mentioned to you what is a syntax errors. Make sure you know that with it. You're containing your executable. You're translating to a machine code with this thing. So the other piece about this thing is there's the JVM, the Java Virtual Machine with this. This is your bytecode instruction on your machine with this thing. The bytecode file is what's called the class file. So the JVM emulates the microprocessor and it actually runs that with it. It's often called the interpreter. Alright. So key things I want you to note out here. I like the slide is you create you save as a Java extension with this thing. Put it through the Java SDK. You produce what's called, assume that you don't have any syntax file. It creates what's called the .class, and then you run the class file, the Java, the name of the class file, the Java virtual machine, that actually in turn returns you the executional program, executes the program with this thing. It's very portable. Portable means that the program can be written from one type of computer, can run on a variety of types of computers. So if I took my source code on a PC and I ran it on a Unix or a Mac, it's going to generate what's called the class file. That class file is run through the JVM. It creates what's called a bytecode with this thing. Yes, that is true. So with most computer programming, portability is achieved by compiling a program for each of the CPU that's going to be run on. So the Java provides a JVM for each platform so that the program doesn't have to recompile for different platforms with it. Here's the bytecode. This is the bytecode. It's the also known as the .class file. 3 types of versions of Java that's out there. There's the standard edition, there's the enterprise, and there's the micro edition. We're using the standard edition here. Most industry, when you get out in industry, they're going to be using what's called the enterprise. It's multi-user, so that's why it's becoming, it has all the bells and whistles in there. Okay? Compiling a program, you need to know how to compile this, right, based off of what we just looked at. Java, make sure you know that. Make sure you know how to run it. Java C, the name of the file and the file extension on it. So here's the programming process you need to know. You need to be able to clearly define it, visualize the program on the computer, and use these 4 steps to actually run through it. Enter the code, compile it. So just read through this, debug it. Software engineering, developing wise with it. I use a technique that's called the spiral techniques. That's out there. I don't use this particular technique per se with it, but just read it. It's there. Everything we do in here up to this point is procedural. Procedural programming is where you break the task down to smaller tasks with it. So anything that you create a smaller task, there's sub-tasks that breaks down that task with it as well. So procedural, procedure, you will hear these synonyms terming over and over with this as well. I want to point out one more thing is what's an object with it. An object contains the data and procedures with this thing. So you're going to see me refer as object-oriented programming. So the object is actually the data, and also includes the procedure in here. And you're going to hear me talk about, when we talk about the UML, and we refer to as what's called class. The class has the field and the attributes of those classes in there with it as well. So in procedural programming, procedures are developed to operate and program data. Data in a program tends to be global to the entire program. So the format of the data may not change. Thus, the procedure operates on the data and must change with it. So what does that mean? These methods that you're going to be writing. You're going to be writing the different types of functions and method. That's what's going to actually change to it as well. Every data object is known as attributes with this. So attributes are what's equivalent called fields. When we actually look at procedures, are also known as functions, and they're also known as methods in here. So these are they're all terminology. I'm just laying the law of the land here so you can understand what's meaning with this thing. So when I talk to you about what's called data hiding, I hope I have a slide here. So if you look at this right here, this is a slide that shows about data hiding with this thing. So data hiding results in only of the object method that's being able to directly access and make the change to the object data. So imagine inside this thing are the data, and here's the object. I mentioned to you the object is the data and the methods that follows it. So this is what's considered as a figurative picture of what's an object with it. And this is what you're going to be writing is this with it. I'd like for you to know this definition. Data hiding is the ability of an object to hide data from another object in a program. This is very important. This is for security with it. So when you come across different type of programming language, you're going to see things that are very, 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 very important that protects the data. In order for you to access that data, it has to go through its methods and its fields for you to actually have access to that with that as well. I'd like for you to know, based on what we just talked about, is some of these attributes and these fields with it. So this is where object-oriented programming comes in. Every object-oriented programming language has to have three things. First of all, it has to have polymorphism. I'm going to talk to you about it has ability to change. 2, it has what's called inheritance. 3, third is encapsulation. And objects like this is what I'm talking about is encapsulations with this thing. Okay. I think that is it. So I gave you the key things you need to know. Make sure you study the things I mentioned to you. Make sure you know how to run it. Let's see here. I'm looking at my notes here. Oh, one more thing, going back to the slide right here. There's a slide here that talks to you about redesigning and debugging and program and when you do all this stuff with it. I'm going to ask you what is the definition of a procedure, okay? So when you look at what, procedural programming here, this right here, I'd like for you to know that procedure is a set of program language statement that together perform a specific task. I'd like for you to know that for me. I'd like for you to know what's an attribute on there as well. There's a slide here that says about attributes. Let's see here. It's not this one. I thought I saw a slide here. Attribute here, right? Data are also known as attributes. Okay, so make sure you know that as well. That's it, folks, for chapter 1. I will roll up chapter 2 lecture. I'll send that out in quickly with it as well.